Today we are discussing about that unit 2 data link layer. In that unit 2, the data link layer, we have the error detection, correction, and introduction, parity checking, LRC, CRC, checksum, harming code, framing, flow control, error control, stop and wait, go back and ARQ, selected repeat ARQ, sliding window, HTLC, multiple access, random access, and channelization, wired LAN, Ethernet, IEEE 802.344, and the token ring, and that FTDI, IEEE 802.11. These are topics we are discussing today. And that error detection and correction, here the data can be corrected during the transmission. For reliable communications, error must be detected and corrected. And errors to be the single bit error and burst error. And single bit error, here the only one bit error in the data unit changes. For single bit error, here the data to be sender side to receiver side, and this is getting that only one bit of changes. So this is called a single bit error. And burst error must be uh, two or more bits in the data unit has changed. For that, getting that example diagram, here the sender side and receiver side getting that length of bits of bus error. Here have the 5 bits. And redundancy error detection uses the concept of redundancy, which means the adding the extra bits for detecting errors at the destination. So redundancy, for example, data generation function redundancy additional data. Here sending to the receiver side, you have the original data to be asserted, otherwise rejected. It's a redundancy concept. For redundancy, you have the checking the data communication, vertical redundancy checks, and they are called the parity check and or longitudinal redundancy check for LRC, cyclic redundancy check for CRC, and checksum. The first three VRC and LRC for the normally implemented in the physical layer for the data link layer. For the fourth checksum is used for primary upper layer. For reduction method PRC, CRC, LRC checksum. Vertical redundancy checks, we have the parity bits we added to the every unit in the so that the total number of ones become the even. For again the data to be checking for the how many numbers ones is there. Even parity generated if we adding the extra bits and sending the receiver side. In receiver check the numbers whether it is a even means the data will be asserted. For LRC, here the original data is there. We have divided the four sections, rows and that normal addition and that original data plus the LRC data to sending to the receiver side. So that is called that longitudinal redundancy. And CRC generator and the checker here the data and the extra bits for divisor and CRC. If the value to be the data CRC is getting the divisor, is getting the remainder value to be 0 means you will accept it, otherwise non-zero means it is rejected. For binary reduction, for example, this sum we have the divisor quotient and that is getting the remainder value 001 and that adding the extra data plus CRC data. Again, you have to divide that in the final value remainder will be 0 means the data will be accepted. This is a RIASC generator and checker concept. And CSA generator is a polynomial time also representation for the divisor concept. So, for example, for the x power 7, x power 6 in this diagram, is where I explained so that missing numbers will be the zeros for remaining things getting the divisor value. For the practice for that student practice CRC polynomial, so this answer will be that easily getting for that CRC polynomial for a previous example. Next one, checksum. The checksum we have the divided into k section. The each n means all the sections are added together in the ones complemented to implement the sum. The sum is complemented and becomes the checksum. The checksum is sent with data. For data unit and checksum, we have the data, sum of the data segment T and the checksum T. For the divided into that k section, for that n bits, all sections added together to use in the ones complemented to get the sum. The sum is complemented if the result is 0, the data are respected, otherwise they are the rejected. For checksum, the sender side check the sum creation, receiver side checksum some validation. The given number is that divided into an 8 number of bits to be that adding that row wise normal binary addition getting that the remaining carry value to that again he adding the numbers and that value to be that changing the ones complemented. That's once complemented he have the changing after that the checksum value getting that the checksum value to original data he have sending to the receiver side adding again he have that the calculation for that one by one row wise we have section wise, so total 5 values we came for that. Again adding for the means we have getting the remainder carry value to adding that remainder side, then getting the one all the ones. The ones complement can change even all the ones will be zeros. The section will be that finally calculated. So this is a error correction method for that redundancy R1, R2, R4, R8 value position for that 10, 11, 9, 8, and then R4 the 7, 6, 5, 4 positions and that 11, 10, 7, 6, 3, 2 positions and that 11, 9, 7, 5, 3, 2, 1. The data and the redundancy bits. For example, formula for the 2 power of r greater than or equal to m plus r plus 1 is a formula for the Hamming code conditions. The Hamming code is in the redundancy of this concept. So redundancy, the data value for the R1, R2, R4 are quotients. The remaining bit quotients will be the data to be added. So R1 R quotients we have to adding the extra bits. The extra bits adding means getting to one type of code, and that one type of code will be that sending the receiver side, getting the receiver side error. The error will be that finding the quotients, which quotient we have to finding for that this the method to we have to quotient for easily using the Hamming method. So Hamming code is an error correction code that you can use to that directly correct single bit errors in the data transfer. Hamming code works by adding the redundant bits in the original data bits. These redundant bits help to identify the correct in any single bit errors in the data. It can detect but also the multiple bit errors. The flow control, we have a set of procedures for using the realistic amount of data can send before waiting for the acknowledgement. Flow control, you have the stop and wait and the sliding window two times method, and since stop and wait, you have the only one frame at a time, and the sliding window, you have the several frame at a time. For example, stop and wait method, you have the sending waiting for the time, wait and then send the next data, wait and then send the data. Like this, you have the data to be sending that and that to the future. Sliding window method, you have the moving for the left to right direction, the several frames at the same at a time. For example, sender to that sender side to receiver side, you have the same direction, you have the receiver for that. For example, big type of sliding window, I have sending the data to that one by one. The data will be not waiting for that command. You have sending the multiple at a time. The error control method, here the stop and wait ARQ on the sliding window ARQ and go back in and select reject. And the ARQ for nothing but automatic repair because here the negative comments came in here, the automatically data will be resent for that. For example, stop and wait ARQ data will be sending for that. The negative comments came in the third question. Error will be the frame 0. So again here the send data will be the error 0 will be sending for that. The stop and wait ARQ lost data frame. The data will be lost. Again the data will be resent for that. The stop and wait lost acknowledgement. Acknowledgement he have lost means again they send the data to be the resent. The sliding in the ARP the damaged data frame. The data will be damaged. The entire data will be the resent for that. Which data position for the acknowledgement negative acknowledgement came from the 3. So remaining 3, 4, 5 will be the resent for that. So again that they go back lost damage frame. The lost data damage frame is that the lost data 2 is a negative comment scheme. So we have the sending for the reason for the data 2, 3, 4, the remaining things. Next lost acknowledgement 3 means we have the completely entire data will be resent for the data 0, 1, 2. Again the negative go back lost damage frame. Selective reject only, selective reject only data will be there resent for that. For SLC, you have the communication protocol for use for transferring data between the device and telecom networking. We have the two types of transfer mode, normal response mode and asynchronous balance mode. Normal response mode, you have that point-to-point communication for the command and response are getting for that, and primary station sending the commands to the secondary station, secondary given to the response pipe, and the two types of response mode to the multiple point communications. So asynchronous balance mode, you have the response mode, you have the sending the both side, you have the balancing for that both sides. So SLC frame for that again flag, address control, payload, and the frame sequence control. We have that bidding for the 1 byte and 1 byte in the variable length. We have types of frames. We have the high frame, S frame, and the U frame. High frame is the transfer the information frame. S frame is a supervisory frame. U frame for the numbered frames. This required for the various functions links like that, setup and disconnections. So multiple access and channelization, you have the random access protocol and central access protocol channelization. Allow CSMA, series, CSMA, CA, reservation, polling, token processing, FDMA, CDMA, and CDMA is there in the channelization protocol. So multiple access protocol, you have the method to use manage for the data transmission network, the multiple device share the communication channel. For example, the classroom, the full of centered when teacher question for the one student, we have sending for the data. The whole time we have that data overlook to be happen for that. So that the time the teacher will be the multiple access protocol to manage the students to make them the answer one at a time. So random access protocol, we have the communication protocol that allow the multiple devices to access the share the communication channel or medium in the random. Random access protocol, you have the types, low types. So you have the aerial location suppressor as of is a random access protocol to use the computer network because first hello in the 1970s. The device can be transmitted and they managed to send two or more devices in the transmit simultaneously. Pure allow, slaughter allow. In this version, the device can be transmitted every time. There is no coordination between the devices. Slaughter allow, the devices into the slots and only allows device at the transmit beginning of the slot, which reduces probability of collision. CSMACD is for the carriers and multiple access with the collision detection. It is a network method to use in the Ethernet network for the purpose of CSMACD to avoid that between that network devices and trying to same time. CA is stand for the carriers and multiple access collision avoidance. The purpose of the avoid the collision between the network devices at the same time as well as manage the shared medium wireless network. Control access protocol allows only one method to send their time to avoid the collision of message at the shared medium. The reaching control access restoration, restoration, polling and passing. On the primary section, here sending the token method. You are calling for the polling method. Data will be resent for that. And the token passing, the token will be passing for the ring type structure. And channelization, you have that TMA, TDM, frequency division multiplexers, time division multiplexers, and the CDM division multiplexers. Dividing the frequency spectrum, PDMA, and use the unique code separate the same frequency band. Ethernet, you have the standard Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet. These are very things for that. Then based by the bus topology, you have the star topology and the star topology remaining. So token bus, you have the following for the token like structure. There will be reason for that. The token ring method is the token ring. We have the passing the message for the token substrate to 8 to 2.5. The fiber distribution time that we have that it's a large LAN extended at 200 kilometers. So it will be 2.11 station or station wireless section based system, extended service set and distributed system. These are that IEEE 2.11. Thank you.